Hi, my name is Sixun Dong, and I'm a postgraduate from Shanghai Tech University in Shanghai. I'm pleased to present our work on weekly supervised video recitation learning to you. This is a joint work with Huazhang Hu and the CVPR lab members. Firstly, what are sequential videos? To introduce our work, let's watch two sequential videos. In these videos, you can observe two individuals conducting chemical experiments, each following their steps. Upon closer observation, you will notice that their steps are similar but slightly different. As the figure shows, the text in red and the green colors indicate two different steps in the previous two videos. It is important to highlight that these sequential videos dataset lack timestamp annotations and only provide the happening order of each procedure. Moreover, the sequence of actions is similar within the same task. Hence, from the annotations of a video, we can only extract the sequence of actions occurring. However, these datasets lacking fine-grained annotations will exist in various production scenarios, but existing methods cannot use such data for learning. The following will first introduce a work which first proposes a sequential video verification task. In this work, they also utilize additional class information to supervise the training procedure of the network. However, our weekly supervised setting does not process in such extra information, but this task can still serve as a benchmark for evaluating the effectiveness of different methods in video representation. Please take a look at these two methods. They utilize video text rooms alignment data and video paragraph pairs as training data for the network. However, such methods rely on timestamp annotations and do not emphasize fine-grained alignment. Then, I will introduce our method's features. We propose a constructive learning framework. Our key contribution is the design of a multi-granularity constructive loss, which plays a crucial role in our framework. Briefly describe our pipeline. It consists of two parts, the variant module and the language module. In the variant module, we utilize a variant backbone to extract frame features from the original simple video, and we employed a transformer to capture the temporal information. In parallel, the step annotations are processed by language backbone to obtain sentence representations. Then we utilize these two representations to calculate the fine-grained loss. At last, we'll calculate the coarse-grained loss by utilizing the paragraph representation and the video representation. The following will introduce our proposed multi-granularity contrastive learning loss. As the animation shows, the coarse-grained loss functions is inspired by the infer-NCE loss. Referring to the coarse-grained loss, a straightforward approach for designing the fine-grained loss is to uniformly split the similarity matrix and then use the infer-NCE loss. However, this method overlooks the issue of temporal alignment, and experiments have shown that use such loss function lead to inferior performance. As shown in Figure A, we utilize the Gumbel softmax instead of the softmax to generate predictions. We then propose two approaches to obtain pseudo-labels. One method involved sorting the maximum indexes, while the other utilized the weight algorithm. Finally, we use cross-entropy loss function to calculate the fine-grained loss. Then, talking about experiments, we'll calculate the normalized Euclidean distance between two video representations and adopt the AUC as the metric for all our experiments. We compared our method with other baseline on weekly supervised video sequence verification task. As Table 1 shows, our method achieved better performance. Besides, the supervised video sequence verification result, which supplies other methods, shows our method's excellent performance. In addition, we also transfer our proposed framework to downstream text-to-video matching and video classification. The results show that our approach outperforms other baselines and has great generalization ability. At last, we have some ablation studies to verify our method's performance. The results show the effectiveness of multiple granularity, contrastive loss, and pseudo-label generation. More details could be seen in our paper. Could have been released. If you need them, please scan the QR codes.